All right, awesome. So we're gonna get started here. So welcome everyone to a Tulip webinar. Today's webinar is going to be 3 ways to calculate overall equipment effectiveness, or OEE, with Tulip. So a couple of introductions as we get started. I'm Gio. I'm the community lead here at Tulip. And with us today we have Grant. Grant, do you want to quickly introduce yourself?
Yeah, hey everybody, my name is Grant Levy. I'm on the customer solutions team here at Tulip. My job is working with customers to make sure they're successful on implementing Tulip and receive value out of it. So I'm excited to share some of the different ways and findings that I've seen out in the field of how Tulip's being used to calculate OEE.
Awesome, thanks, Grant. All right, so we can get started here. Yeah, perfect. So just briefly, as we get started in the webinar, I want to go over a couple of the objectives for today's webinar. So really it's split up into 2 main parts. First of all, we'll be going over what is OEE. So a couple of definitions, there are varying definitions, so we're going to study all of them. The simple calculation, the formulas, and then full OEE with machine. And then part 2, and actually in between there, we'll have a quick about Tulip section. So for those of you that aren't familiar with what Tulip is, we'll be describing what Tulip is and what the platform can do. We'll have a walkthrough with some app use cases. And then we'll be moving beyond OEE with benchmarks and OPE. Great. So at a glance, this is what we'll be going over. We'll be getting started with what is OEE, the introduction to Tulip, like we mentioned, calculating OEE with Tulip apps. And here Grant will be doing a live demo. Then we'll be talking about moving beyond OEE with OPE. And then finally, we'll be opening up to Q&A. And I would like to mention that if you do have questions at any point, feel free to submit them through the Q&A button at the bottom of your screen here on Zoom. Okay, so we're actually going to do a poll in today's webinar. So, just to help us understand, folks' kind of use of OEE and what it's like in your facilities. If you could just answer the question, do you track your OEE? And you should have gotten a poll opened up. So the potential answers are yes, we track OEE in all our machines. Yes, in some form. No, we don't track OEE, or I don't know what OEE is. So yeah, if you could just submit the poll between now and in the next couple of minutes, that'd be great. Perfect. Next slide. Okay, great. So we can jump right into it. Grant, could you get things kicked off with a definition of OEE?
Yeah, so OEE is a relatively standard or industry standard metric that allows for the scoring the typically the productivity of I say machine, but hopefully by the end of this webinar we'll actually see that we can actually go beyond a machine, and we can treat assembly cells or lines as like individual machines to track OEE from, but it's a metric or a score that's applied to a particular machine to understand its real-time effectiveness in comparison to ideal conditions or its capacity. So we're going to go through a couple different formulas here for how we can really score or view OEE. One thing I want to make clear from this entire presentation is I don't want to be like overly prescriptive as to how OEE gets calculated at an individual facility. I think there's kind of standards where with how that metric gets applied, but I've seen it done in a variety of different ways, and ultimately it's going to be a tool that you can use to help value what's important to you in terms of productivity, and to make sure you're getting key indicators out of it that can help drive continuous improvement. So continuing on here, these are the 3 different kind of mechanisms or ways that I'm going to be reviewing to calculate OEE. The first is going to be a very simple it's a relatively like single formula that, you really just need a good part count and, some ideal run rates, and you'll be able to actually get like a really high level, lightweight OEE. But you can expand upon that metric to get more accurate and real-time data with the following two mechanisms. The first one being expanded OEE. Now, if you're, we'll get into what all of this means, but this kind of takes the approach of the standard availability, performance, and quality portions of OEE. And then we'll get into full OEE as well, which, really what I want to introduce here, and we won't have time for the entire webinar to get in depth, but what I want to introduce here is the idea of machine monitoring in Tulip and how it can help facilitate and really automate some of this OEE data collection for a particular machine. So hopefully, once we get to the end of the webinar, and again, I'll be happy to answer any questions at the end, but hopefully that, these are kind of stages of how you can roll OEE out from a a simple orientation to a more complicated, with obvious values or benefits from each mechanism. So getting into the simple OEE formula. Now this is relatively basic. If you have a good part count coming off a machine, and you also have the time spent or the time planned for whether it be a shift or a day, or even smaller chunks of time, as long as you have a part count and how long you were intended to be operating for, you can use like an ideal cycle time to understand where in that process you really fell, right? So ideally you are making a part for every within every duration of your ideal cycle time. You're making one part. But oftentimes that's not the case, and you may have downtime reasons, you may have other events that impact your production schedule, and this is again, this is a really lightweight way to like review that information. We're also gonna later on in this presentation, I'm gonna get into this idea that OEE as a metric or a number really it doesn't tell you all that much. It can be really helpful from like a real-time perspective as to how your machine's running. But in terms of this idea, or in the spirit of continuous improvement, there's other ancillary items along with OEE that we really need to be cognizant of, especially when we design applications in Tulip, or think about all the contextual data that we can receive. Because that's going to be what helps drive a lot of this, and so we'll get into that later on in the webinar. Looking at the expanded OEE formula now, again, it looked like many of the folks on the call are aware of what OEE is, which I'm not surprised about. Again, I think it is this term that comes in all shapes and sizes, but again is recognizable throughout the industry. But the kind of expanded OEE formula plays on this idea of taking an availability metric, multiplying it by a quality metric, and ultimately a performance metric. Now, looking at the actual kind of definitions of availability, quality, and performance, we're really left with, availability is, the running time spent on a machine divided by the scheduled runtime, right? So if you were scheduling a machine for an 8-hour shift, but you're only able to run for 6 hours, you'd be looking at 75% availability. Now, I will say there's some, I don't want to get into a whole, discussion or debate on, the merits of OEE or OOE or OPE. We'll talk a little bit about that later. But what I want to show in this demo is that like this definition of availability, while this is the working definition that we'll kind of take up for the duration of this webinar, this really is flexible based on what you guys may see real time in your facility. So you may have maybe there's certain reason codes or downtime reasons that like you really don't want to impact your availability metric. That it can ultimately be it can be flexible around that. Looking at quality, this is pretty self-explanatory. It's your acceptable units divided by your total units produced, and ultimately your performance we can think about it as throughput, divided by your overall throughput. Another kind of way to phrase that would be, we can take our good parts made, or our total parts made, divided by our ideal part rate, given the time or duration spent running. And we can start to compare essentially, the units that we've actually made versus the units that we should have made in that same duration of time. So those are our three kind of components of our calculation. And once again, if you multiply them together, that would be kind of your expanded OEE definition. And we're gonna cover how you can actually collect this data in Tulip through a variety of different ways a little bit later in the process. Lastly, it's this idea of full OEE. So it's not, the definitions in this case for availability, quality, and performance, I'm not necessarily changing, but this goes back to that note about contextual data, along with machine monitoring, which can help facilitate some of this data collection. So, again, I noticed a lot of people on the call weren't necessarily collecting OEE, and I'd be curious to hear in like the Q&A or the comments section, if that's because there's current like blockers that prevent people from doing OEE that maybe Tulip as a digital solution can be better suited to tackle, or if there's some concern around the metric in its entirety. But with machine monitoring, if we think of two ways that we can really collect data, we can have operators manually filling out like maybe it's like an end of shift form to report on their production and any reason codes or downtime events or things like that have come up, or machines, a lot of machines, at least newer machines, they have internal signals or tags that change as the machine changes its operation. So we can actually use that machine to give us real-time signaling of when we can actually indicate that it's down or it's not running or it's producing parts, and we can use that data to really automate the collection of all of this. And again, that alleviates the need for any kind of transcription of a shift data. It also allows for real time. You can view a dashboard, and I'll show you an example later on in the presentation. But you could view a dashboard of your real-time status of any machines across the line, and get a sense of what the current state is, without needing to call down to an operator or interrupt any kind of workflow. So we'll go through a couple different, or like an example of this as well, and then we'll also kind of expand on this idea of like downtime reasons and contextual data that allows for us to really reach a second level of our analytics that can be used to drive continuous improvement. Ultimately, OEE without that contextual data is ultimately like a diagnostic metric. So it's really easy or helpful to be able to see that your machine maybe is running at 50% OEE because you understand that there's some lack of efficiency there. But that's all you really have with just a number. You really, maybe your availability is low, but if you don't know why the machine is down or what your common downtime reasons are, it can be really hard to just generate value from that number inherently. It can help drive attention, which is great. But Tulip can do a whole lot when it comes to collecting this data, but also providing context that allows for a second level. And what I mean by a second level is if I see a machine is down, but then there's it's up to an operator to now say okay, my machine is down. I'm going to troubleshoot the downtime reason. It's down because of reasons X, Y, or Z. And now now we can report on our overall downtime. How common is downtime reason X, Y, or Z? I think in this world of continuous improvement and data analytics and being able to use data as actionable intel, that is so key for driving an operation. Being able to say, okay, for our last month, these were our 5 most common downtime reasons. How do we start addressing the problems here? because that's ultimately, that's going to be where you can really gain back some of your productivity. So hopefully that makes sense. Again, if there's any questions, feel free to post them in the Q&A box. But ultimately, OEE, it provides you of an overview of the factors that like make up efficiency, and it presents a really strong opportunity to drill down for these secondary reasons. The benefits of being able to not only identify OEE but also have this contextual data in place can ultimately lead to improved quality, higher first pass yield, less unplanned downtime, higher machine utilization, more accurate cycle times, and kind of as a addendum to those last 2 points, it can be really easy to get a sense of like overall bandwidth throughout your equipment, right? So if you're looking to scale your production, this can be a really easy or useful tool to help understand, hey, I have 5 of these one machine that are 80% efficient. I have 3 of a different machine that are 50% efficient. You don't necessarily need to scale up linearly across the board to meet demand across the board. So I understand that's maybe a little bit of a simplified example, but this can be a really useful tool or metric to help start identifying some of that data.
Awesome. Thanks, Grant, for walking us through what OEE is and the different ways of calculating it. So Grant, in just a minute here, is going to go into a live demo of a couple of applications that are using using Tulip. They're calculating OEE. So, but before we get into that, for those of you who are joining and are not familiar with the Tulip platform, we quickly want to go over what the platform is and the kinds of things that you can build on it. So Tulip is a manufacturing app platform with 3 main components that I'll get into in just a second, but it allows you to build complex apps to automate your workflows in your facilities. So the 3 main components, as you can see here, starting from the left, is the app builder. So, accessing it through Google Chrome, you can go in and you can envision it as a very, very powerful platform in which you can build complex apps without writing a single line of code. So, you can go in, open up your account, drop all kinds of widgets, buttons, rich multimedia, and then prepare your apps that then run on the tablets on your shop floor. So it's, like I said, it's self-service, so you don't have to write a single line of code. It's all drag and drop and very intuitive. Next pillar here is IoT and system integration. So Tulip has a lot of, through a lot of protocols, can communicate with either hardware devices that you have in your factory, whether that's, like things like torque guns, measuring devices, scales, these types of things. Even more, more complex things such as big machinery, CNC machines, injection molding machines, you can connect to them through OPC UA. And also using other, software connectors, you can connect to existing systems of record. So if you have an ERP that you're using and you need to connect to it to get data out of it, you can very easily do that using the connectors portion of the platform in Tulip. And again, all this is still within the no-code platform. So it's, it's all very easy, drag and drop, and it all works together seamlessly. The last portion here is analytics. And I think this is really important because, we're collecting all this information. You have apps that are running on your shop floor, but it's really, they become powerful once you can take actionable decisions upon it. So you can see, okay, there is a specific area of the facility that I need to focus on, or there's a specific process that needs adjusting. Surfacing all this information makes it very easy to decide where to start your efforts. Awesome. Next slide. Perfect. So what are manufacturing apps? So Tulip apps turn your workflows into instrumented data collecting digital processes. So if you walk through a plant right now, you can imagine there's lots of pieces of paper that are recording information that, but fundamentally they're keeping this information in silos and it's not getting distributed. So with manufacturing apps, you're very easily able to collect information, and then distribute it to those who need it. So you can see here, they look, you can design them any way you want, and you can make the interface, you can customize it very easily. But it's, you can see here they're lean, they're visual, they're interactive. So they connect with machines, tools, and sensors, and humans. So you can ask the operator or the team member to go and input specific metrics or click buttons to record information. They're data driven. So either from things that you declare or just from running, they're collecting information on your process. And they're intelligent, so you can very easily go in and customize the apps to suit your specific process. So, we often see lots of trends among facilities, but then there are a couple of little differences. So Tulip makes it very easy to go in and tweak it to fit your specific needs. Awesome. So today the demo will be covering an OEE app, but we did want to mention that, you can use Tulip to do many other things. Here you can see a handful of some of these other things. So for example, complex assembly guidance up at the top left. So, if you have a process that has lots of combinations, it can be very easy to make mistakes. With Tulip, you can very easily poke your process and put controls in place to avoid these defects from happening. Just below that, defect tracking, so if you want to record information on when defects were occurring in your process, has to surface and see trends on, whether it was a specific shift or a specific process or a specific product that is causing most of these defects. You can very easily set up apps to track the defects. And the list goes on, but I think the important thing is that once you have Tulip as a tool, it really becomes very powerful in terms of the things you can do, and the possibilities really are pretty endless. Okay, great. So now that we've gone over a little bit about what is OEE, you've had a quick introduction to Tulip. We're actually going to go into a demo to see what how we can actually use Tulip to calculate OEE. So Grant, do you mind walking us through a quick demo of some of the apps?
Yeah, I'd be happy to. So OEE with Tulip. We're gonna cover two different use cases. One that kind of addresses the manual collection of this data, which is really a lightweight way to get started with Tulip, or to get started trying to calculate your OEE. And then I'm also going to share a couple screenshots and speak to a full OEE calculation using machine monitoring, and try and walk through a little bit of that. Again, I don't want to delve too deep into the machine monitoring world, because I think that's worthy of a webinar itself. But again, if there's any questions afterwards, I'd be more than happy to help. The screen that you're seeing now is it's the same app that a screenshot was shown on one of the slides Gio was just presenting. But this is an application that has come out of our reusable content, or our library, our app library effort that Gio is going to talk a little bit more about after the fact. But the idea is this application, is a single page application that is available, for any of you on this call or anybody who may be watching the recording. This is available to be put on your instance immediately, and it'll come with some documentation as to how you get it set up. It's pretty minor in terms of setup. It's pretty much functional out of the box. And this is, hopefully from this demonstration, you'll be able to understand that this is, a very easy way to get your foot in the door with, whether it be Tulip, if this is, if Tulip is a new product for anybody on this call, or, if you're doing other things with Tulip, but OEE has always been an interest, this is certainly an easy way to kind of explore the value that you may receive from some of that data collection. So just to review for anybody who's not familiar, this is the Tulip web page. So this is a Tulip instance for our library content. So this just runs in Chrome, and I'm currently on this app editor step. So, everything on this page is, drag and drop, no code development. If I wanted to add a new button to this page, all I'd have to do is come up to this upper menu. I can press, the button, and now I have a button that I can, play around with, how I want it to look, what I want it to say, and ultimately, I can add trigger actions to change how I want it, like how I want it to act. Now, this isn't meant to go through, any of that kind of basic Tulip app builder platform, but I do want to emphasize that everything you see on this application is easily customized to your own needs. So you may say, I have no need to, we don't report on operation numbers, for instance. Great, if there's other data that you care to see, it can be very easily substituted, or otherwise, you can remove some of this and make it a simpler interface. But so everything on this application is customizable, and that includes the actual calculations that are being used for availability, performance, and quality. So if I click in this calculate button and I open up this trigger, the logic, again, I don't want to walk too heavily through this logic. Let me zoom in a little bit to try and make sure you can see, but we have our calculations for availability, performance, and quality here. This is all something that can be very easily customized, again, based on however you want. If you want to slightly modify what you consider to be available time, great. This app provides a starting point, but it's really intended as a template or a canvas for you to modify in whichever way. So now that now that I've gone through the app editor side, and hopefully, we're all understanding that this is a drag and drop interface, and the logic here can be, customized. You don't need a software engineering degree or anything, or computer science degree to do this. I'm going to switch over to the Tulip player. So this is where your Tulip applications that you build in the app editor, this is where they actually run and get executed. And this is what will collect the data and ultimately be used for visualization. Now, the general flow of this application is you select a machine. Again, I'm using machine loosely here because this could easily apply to an assembly line, even if you wanted to report out on an assembly line or a cell. But you would select the machine that you want to load. This is using a Tulip table to populate so that we provide a standard list of machines for operators to select. That way, we're not relying on plain text kind of matching up and having to do any kind of complex matching that way. Just to highlight what this table looks like. So we have this OEE calculator machine list table, and you can see Arberg 1 and 2, I have them in the injection molding department. This is just metadata that'll become more obvious as I look at some of the analytics. But this is pretty much the setup that's required for this application, is to provide the list of machines that you want to use to this. And the rest is, pretty much working out of the box. So coming back here, I can select, I'll select Arberg 2. I might say, hey, I'm working on part number 4. I'm operation 1. Maybe I have a work order attached to this. This data isn't required for any of the calculations. This is, again, it's a way for us to provide logical kind of partitions to the data that we collect. So if you ever wanted to go back in and visualize your data for, a particular work order, or a particular part number, if you wanted to get a sense of like, hey, my OEE when I run part number 4 on average is this, we have that logical partition in our data to divide things that way. So this isn't required for the calculation. This middle section is actually where a lot of the calculation is going to be derived from. Now, for availability, we're going to be looking at our runtime out of our shift length. I think minus our breaks. So we won't take into consideration our breaks, but everything else within a shift length is considered to be available or scheduled time. Again, this can be easily modified to whatever suits your operation. But I'll go ahead and put in 480 minutes. I think that's an 8-hour shift. And then we'll, for a runtime, we'll say, I ran for 400 minutes. Maybe I had 30 minutes of break. Maybe I had a 10-minute setup time, and my actual time versus standard. We'll say I met my standard time. And now this downtime, which is kind of the last bucket of time, we could easily have this auto populate. So, there's 400 minutes here, 300, 10, 10. So, we'll ultimately have 30 minutes of downtime. We could have that auto populate. That's a pretty easy modification to this application. But here's the first example of that contextual data that I wanted to provide, in addition to, the part number, operation number, and work order. I can actually select a reason code for this time. And you see here, I have a few different examples. Again, this can be easily customized to your own list. Maybe I'll say we had a dull tool, and that was the reason for a 30-minute downtime. Let's say that my standard, runtime per part was 60 minutes, and I only completed 4 parts, and I had 2 scrap parts or something. And here's another example where I can, put in a reason code. Maybe it was the material, and I could put in any context notes here. So, dull tool was corrected and advanced forward. So you can have context here that gets captured as well. Now, the first thing I'm going to do is I'm going to calculate my values so I can actually see, my metrics. I had 90% availability, 80% performance, 66.7% quality. And ultimately that gives me an OEE just under 50%. I could change, any of these values. So, for instance, if I really only had 1 scrapped part, we could change this as well. And we see these metrics change. But ultimately, again, I'll say it one more time. These calculations that we use here can be, customized for however, whatever, a client or customer really how they want to show this. Now, the key to this application is when I calculate and submit, all of this data is going to clear, and it's going to go into our completion data within our Tulip application. So if I open up the OEE calculator here and I go to completions and I show all data, we can see that it took me, since I had opened up that terminal already prior to this call, it had taken me 3 hours to kind of complete that report. I did it for Arberg 2. This was my availability. Here is all my data around, breaks and downtimes and Dell tool. All of the data effectively gets captured here. And this is our way to visualize the raw data. But if we go to the analytics tab here, this is where we can really start to, this is the value that you get from Tulip, right? So these are just a couple example analytics that I've already built. If I'll open up this weekly performance for injection molding. So what we see here is I have my expression for performance. And, right now I'm looking at the current week. I could change this to look at today, with the click of a button. And now I can get a sense of, hey, what was my performance across all injection molding machines? If you remember, I've attached a department here to these Arbergs. So this is the metadata that it's really kind of making this logical division on, which is why it's, this isn't required, but it can be really helpful for you to visualize different parts of your facility. But I could also, maybe instead of this, maybe I wanted to say, I want to see where my machine ID is equal to Arberg 2. And now we get, slightly different values for when we're looking at Arberg 2 versus Arberg 1. Arberg 1 hasn't had a completion today, but if I look at yesterday, we see that it was, 79% yesterday. So this is really, this is where the value from, up until now, we had digitized a form that might be standard throughout your process. But here, all of that data, with a click of a button, without requiring any additional transcription, it becomes stored in your completion data for you to perform this analysis on, for the rest of time, theoretically. So if you ever wanted to compare, last month versus this month, or this month last year versus this month this year, you could always do that with Tulip data, which is a really great thing. And the fact that it's so easy to I could look at yesterday, but I could also as easily just look at my all-time data as well. So this is, one example of a metric, but again, this is just the number that represents, one of these breakdowns of OEE. If I go back to my analytics, I want to show a little bit just this Pareto, right, that I'm starting to talk about of contextual data, right? So I might see that my Arberg one has an availability of 50% or whatever, give or take, for a certain period of time. That doesn't tell me a whole lot as to what Arberg one is actually suffering from at any point in time. So it's this second level Pareto that really allows us to say, okay, we had 80 minutes of broken tool, and we had 20 minutes of unplanned maintenance. Now we could even go take it a step further, and in that application, if you selected broken tool, for instance, you could actually report on which tool was reported broken or which general facet it was reported on. The key here being you can really drill down as deep as you really care to go. And again, if I wanted to switch back over to Arberg 2, I just reported 30 minutes of dull tool. So these analytics are, they're staying up to date real time as well. So you could build out an entire dashboard showcasing all of your different lines that you care about, or machines that you care about that is getting this app, completed against. So, this is the contextual data that I think really makes OEE a valuable tool, because, if you see that dull tool is your most common defect reason or downtime reason, you can, it helps you identify where you need to expend effort to try and help, reduce that, whether it's coming up with a better, for a dull tool, maybe it's a better PM schedule, or maybe it's just adding to the fact that like a better reporting system for, if a dull tool does get reported, let's send an alert to a maintenance team that can get there quickly and, hopefully, drive down downtime that way. So hopefully that all makes sense. There's infinite different ways we can really splice this. So I don't want to, go too deep on any one thing. The last thing I will say about this application is this wasn't intentionally built where you could have one station being like one instance of this application. So whether it be a tablet or a PC in your facility, you could have one station run this app for the entire facility. And people could just wander over after their shift. You could also run this app on 100 different tablets across your facility. Every line could have one theoretically. And that would really it wouldn't impact the way the data gets collected at all. You don't even, right now I have shift length. So ideally, theoretically, you're putting in a single shift's worth of data. But really, you could be reporting this on any breakdown of time. So, you could report every 30 minutes if you wanted to, and that won't impact the way that this app reports out on data. So hopefully, if you have any other questions on this app, let me know, whether it be in the Q&A or you can feel free to reach out to me as well separately, and I'd be more than happy to help. Getting back into the full OEE with machine monitoring. Now, this is, the idea here is similar to what I just showed, except rather than having an individual be responsible for reporting, hey, we had 400 minutes of running time, 30 minutes of downtime, we rely on machines to indicate to us, are they running or are they not running? Are they producing a part or are they producing a defect, for instance? Now, part of the reason why I don't want to go too deep here is it can be heavily dependent on the individual machine. So Tulip can connect to anything that can output an OPC UA signal. A lot of folks use a middleware software, like a Kepware or some other OPC translational service that maybe converts common machine protocols to OPC UA. But we can actually take these machine tags in if they speak OPC UA, and we can make decisions based on tag values, right? So you might have a machine that's very obvious. It could say, it could have a tag that's, maybe it's a Boolean tag that says running, yes, no, good part, yes, no, or like bad part, yes, no. And you could say, hey, if my machine is outputting a running state, then I'm going to count it as running. If it says false to like running state or available, then I'm going to report it as downtime. And same with, the good part, bad part. Or, you may have to get a little bit creative depending on what tags you have available. You could use other sensors, including, a Tulip gateway with break beams or other sensors to determine, if parts are coming off a machine. So I don't want to go too deep into that side of things, just because it could be so highly versatile based on the machine types. What I do want to show just quickly is what that machines page actually looks like. So we have a couple demo machines set up here. So one of these is like a Machino. And you can actually see, if I go to configuration, these are all demo tags that we have outputting data to Tulip. So for instance, this has a part number, it has a spindle speed, it has a status, it has an alarm type. We can use all of this data, depending on what it means to help drive decisions around this machine. So for the Machino in particular, the way we've built this out is, if the spindle speed is greater than or equal to 8,000 since our last output, we'll say it's running. Otherwise, we'll determine it to be stopped. So again, there's, depending on the tags that your machine has available, there's different ways to, help make that determination. But from a Tulip application, the machine might indicate whether it's running or not running, but the machine probably doesn't have that second level of context that we keep talking about, where why is the machine not running? It may say, hey, I'm in a manual mode, or, hey, some alarm went off. But it can really be it becomes the burden, or the burden becomes goes to the operator to then say, okay, not only is this an alarm, but it's an alarm because X, Y, or Z. We're in a changeover. Maybe it was a broken tool. Maybe it was a bad part got stuck or whatnot, depending on the type of machine that you're using. And here's an example of what an application that provides that context might look like. So right now, this machine is listed as idle because its downtime reason is no demand. Idle states are another kind of addition to OEE. Maybe it's an expansion on OEE where, if you're no demand would mean that you're really not scheduled to run anything. So you don't want that metric to go against your availability. But you can see here, there's a bunch of different buttons to indicate that a particular downtime reason, and that can ultimately feed back to some of the metrics that we see here. We can also report defects, and I don't have a screenshot of it, but that defect might have several different reason codes as well. So all of these Paretos that I'm showing for downtime reasons are applicable to defect codes as well. Now, what this allows you to do is you can actually build dashboards similar to this, where you can actually at a single glance from anywhere within or even outside your facility. You could be on a flight somewhere, and if you have internet access and can get to Chrome, you'd be able to see what the status of your machines are at any given time. Here we have red indicates that the machine's not running, obviously, with this yellow bar indicating that it's not running, but it's actually in no demand. We have reason codes listed here, along with all of the different metrics. So this is it's a really powerful way to start building these dashboards. But also, the machine is giving you real-time information, and then it just becomes, how much the operators want to, how much they can get involved to provide context that drives that continuous improvement. Hopefully that makes sense. If not, I'm happy to go into that a little bit more. But the idea here is, regardless of whether or not it's manually collected or automatically collected, OEE, there is inherent value in an OEE metric, but I think you lose some of the potential effectiveness if you're not capturing all of this data around it, because that's really what, if you just want to kind of stay steady flow and ensure that your machines are kind of running as you expect, great, then OEE may just be all that you need. But if you're looking to consistently push your line to be more productive, I think the second level of data will be a requirement when considering OEE.
Great. Thanks, Grant. That was a really good description, and thanks for doing the demo. Now, really briefly, would you mind going over, if we were to move beyond OEE and into OPE, what that is and how that can be calculated?
Yeah. So OEE, we talk about OEE as like an industry standard. I think there's uh, several different flavors of OEE, one of which, would be OPE. There's OOE, every acronym under the sun. And to me, OPE really, as the slide depicts, it's really about adding like a factor that's really inherently hard to capture from machines, which is that human factor of if you have an entire process that maybe a machine outputs a part, but that part then goes to an assembly process, and you want to capture that entire value stream. A single like OEE metric from a machine is only going to tell you so much about a process. So OPE really it tries to loop in or connect those typically disconnected portions. And so hopefully Gio, I think you alluded to it on a previous slide when covering all of the past use cases or other use cases that Tulip is being utilized for. Hopefully that provides some level of support for this notion that Tulip is effectively a tool that allows to connect humans to digital value streams. So whether it be work instructions or other processes that are used to measure human performance, Tulip I think excels at a lot of those. And again, even like these OEE applications that we're talking about could be factored in. You could I keep referring back to the OEE calculator application, but it's not necessarily restricted to just machines, right? You might have an assembly cell that has a line leader that maybe your production's being tracked on an hour by hour basis. You have standard takt times and standard work that you're following, and ultimately like that performance coming off that line is also getting measured in a certain way. So Tulip can really help combine, hey, like let's look at this process holistically. Let's evaluate the entire effectiveness and combine those different value streams. So I don't want to go too in depth. I want to, I guess, leave some time for questions. We have more information at tulip.co/resources. So if you're interested in getting an idea, between OPE, again, I think, there's also, some of these definitions are, it may just allude to the time that you consider when looking at what is, typically thought as available time. But
Awesome.
yeah.
Yeah. Thanks, Grant. So yeah, hopefully that if you don't mind going to the next slide. Yeah. So hopefully that kind of gave an overview of what OEE is, how it can be calculated. But I think one really important thing to bear in mind is that it's like you can calculate for your specific facility the OEE very easily, set it up, customize it. But at the end of the day, you really want to see the benefits from surfacing all this information. Because otherwise, if you're just recording for no reason, it's not that useful. The benefits really come, and you can see some of them listed here, and Grant went over them earlier. But once you're able to surface this information, get it into the hands of people that can make decisions, that can impact how a facility is run, then that's when you really start to see this transformation. You start to see improved quality, higher first pass yields, less unplanned downtime, higher machine utilization, more accurate cycle times, amongst other things. I think a lot of the benefits are also kind of determined as you roll out the Tulip apps. Great, next slide here. So we did briefly want to mention about the Tulip App Library. So Grant mentioned that the OEE calculator is part of the library. So the library is an effort that was started some months ago, and it's essentially a set of curated apps that are developed by the Tulip team with all kinds of use cases. So It's being organized by bundles. So, whether it's a machine shop bundle or it's a checklist bundle, every 2 weeks we have releases of apps in our library that you can just go, we can add them to your account and you can use them out of the box without, without having to build or without having to do anything. Just once you get them in there, you can start using them. Of course, if you do want to tailor them, you can easily go in and tweak a couple of things and make them fit your process. If you're interested in the Tulip App Library, you can navigate to community.tulip.co. And in our announcements section, you'll see all the recent releases of the app library, and you can get in touch with us there to have these apps added to your account. Perfect. So thank you all very much for joining. Hopefully this was an insightful webinar. So we've already had actually a couple of questions come through, so we'll be answering those in just a couple of minutes here. But while we let other folks ask questions, and actually, Grant, if you don't mind going to the next slide here. We did want to mention that there are some upcoming webinars. So the first one is going to be on September 23rd, where customer success managers Eddie Atkins and Jessica Yen from Tulip will outline what it takes for enterprise multi-site deployments of Tulip to be successful. And then on October 1st, I'll be going through with Mark Friedman from Tulip to discuss process audits. So those are the 2 upcoming webinars. And then Grant, if you go back to the previous one real quick, the last upcoming event I want to talk to you about is the Agile Manufacturing 101 series. So this will be a series of events starting on October 14th at 10 a.m., organized by theme. And this first one on October 14th will be on small and medium businesses. So, we're going to be sending out an email following this webinar, and there'll be links in there for you to sign up. So yeah, thanks again for joining. Now we're going to go in and answer a couple of the questions that came through here. So Grant, you want to get started with either one of them, or how do you?
I'll be honest, I'm having a little bit of difficulty opening the Q&A. So if you want to read them out.
Yeah, for sure. So the first one here is OEE app required manual key in data for calculation, which is the same as Excel. Can OEE app link to MES to collect data and calculate automatically?
Yeah, so that's a really good question. So Tulip, as Gio mentioned, Tulip has a standard kind of third-party connector function. So we can connect to anything that is SQL based. We can also connect to anything that provides suitable HTTP API endpoints. So depending on your MES system, I suspect that one of those 2 are more than capable of being communicated via, either of those protocols are suitable for communication, I would assume. So you could very easily, when you're reporting, you could easily build in functionality where maybe you scan a part number or process, and that goes to MES to collect any information about that you care to submit with. But we can also write back to your MES. So if you would rather, if you have your suite of applications that you're already comfortable doing all your data visualization, and we could certainly write back to a system. I know a lot of folks like to use a Power BI software or something to do their actual data visualization. In which case maybe it's a SQL database that we write back to that Power BI software has access to. But it's the same for MES. We do support read-write functionality on both fronts. It's not included out of the box with this application because it's the purpose of this is to provide a generalized template. But yeah, that would be more than enough to that functionality is certainly available in Tulip.
Yeah, it's a great question. Thanks for asking. Okay, I'm just seeing here because it looks like there was another one that was answered live here. Um, okay, so involving the operators is critical to success. Is there an easy input for operators to participate?
Yeah, no, that's again a great point and question. I think my job, my day-to-day job is building interfaces, for a variety of customers and working with operators. And I couldn't agree more that making sure that they're comfortable with the tool that they're using and they've been able to provide guidance on is critical for any kind of adoption to be successful. So the application in itself doesn't by default have any of that, like a reporting. Let me just open it up back here. It doesn't have a feedback built in, but something like that could be really easily added. So, again, this idea that it's customizable, what I would imagine you'd want to do in this case, and I think there's other template applications that may be available on your Tulip site that use a similar kind of app structure, but you could provide a button that says provide feedback, and that feedback could have a comment field similar to how we have a comment field down here, and when you submit, you could send an email directly to whoever wants to own this application for the facility. You could send an email or a text message directly back to them. You could complete the app so that feedback gets stored, and maybe if you had a daily or a weekly management meeting for your lines, you could review any feedback for the application. But I think the best thing to do is when you get this application, you can walk through it a few times with an operator present. And, if you're not comfortable modifying this application, if it's maybe the first time you've worked within a Tulip application, we have other resources that would be, this app is pretty, I would say, low level in terms of, sophistication from a Tulip perspective. So, adding functionality like that or any other functionality that you may want to add, if you sit through a Tulip University module, I think you'd gain the skills necessary to really own this. That being said, this is an application that we're looking to provide to folks, at will. So if there's any feedback that you have for the application that you think, extends beyond your individual, individual site, I'm more than happy to kind of listen to that and work on a second version of this. And I think the feedback is probably a great, that feedback mechanism is probably a great, suggestion, especially when, this is a tool that we're looking to take from generalized content and roll out immediately. It may work, for you, but it may not be the way that, people on the floor want to see it. So I appreciate that feedback. And I think that's something that, again, we could issue a second version of this with that, along with any other feedback that, comes out of this.
Awesome. Thanks, Grant. So it looks like all the questions have been answered here. So thanks again, everyone, for joining. Thanks, Grant, for all the insight and the demo. And we look forward to seeing you on upcoming webinars.